We had a good childhood. It was a free life. John was the youngest of 5 of us, and we had a big double garage at home. He used that as his little lab, and he used to blow a few things up in there. Probably Mum went grey before her time.
As a young student, John was very keen and eager to learn and was also very personable.
People often say, oh, he must have been exceptionally bright to do what he's done, but in fairness, he always was a hard worker, even from a young age.
The special thing about John was that he had many strings to his bow. He was not just an outstanding student, but he was an impersonator. He could write scripts for pantomimes that were produced by the department, and he was a rather nervous firewalker, of all things.
At the University of Auckland, John is one of our heroes. He has inspired so many young scientists, not just to stretch their wings and become great scientists themselves, but also to lift their own ability to think and grow and learn and contribute.
You don't become president of the European Physical Society without being held in high esteem by your peers.
I think John's scientific legacy will be twofold. His body of work stands for itself, but I also think his leadership in the community will make him an icon for a very long time.
When it comes to status within physics, John would be an All Black, and a very brilliant one.
When I think about the Alumni Award for John, I really feel that it is deserved. He spent 40 years of his life working really hard. You know, it's fine getting awards overseas, but this is his home, so it's really special.
The 4th Distinguished Alumni Award is presented by third-year PhD student Matthew McNaughton from the Faculty of Science. Matthew is part of the leadership team of the student chapter of the international organisations Optical and SPIE. Last year he was co-chair of Koala, a conference organised for students by students. Welcome Matthew and distinguished alumnus John Dudley.
John, why are you a nervous firewalker?
Well, I think firewalking can be explained completely rationally and without any need for superstition or
It's only physics.
pseudoscience. But still, the human spirit is that when you're confronted with 3 meters of glowing embers and flames, something says, I shouldn't really be doing this.
I love that it was presented not as a criticism, but as it was an unusual observation that John should be a nervous firewalker.
Well, Professor Putt's Australian.
Yes, true. In doing our research, I came across this quote I wanted to share with you, John. When John was aged 12, his older sister and her husband used to go to their mother's house every Sunday for dinner. At that time, John and his brother-in-law, who was 24, used to get into such heated discussions over algebraic equations that John's mother had to take her son-in-law aside and urge him not to get John started. Where did that passion, as a 12-year-old arguing with someone twice your age over algebra, come from?
I think the great thing about science and the great thing about physics, and especially because it's seen as like the most annoying part of science, because it's the physicists just don't let anything go without question. And they want to search for absolute truth. And it doesn't matter who you're talking to. If something's wrong, you should learn to accept it, and you should not be afraid. Anyone should be afraid to correct anyone else. And that's something that we see again and again in science, where even some of a great Nobel Prize winner from the early part of the century, he deliberately invited questions from annoying students at the back because he knew that the older ones would be too afraid to ask him questions. So I wasn't really afraid of my brother-in-law, and I'm still not afraid of him.
Well, in the spirit of correcting errors, please do not hold back in correcting me as I try and explain some of your core research here. You have taken the mathematics of how light behaves in optical fibres, and you've found the same equations describing rogue waves in the ocean. Is that correct? Freak waves, the kind of waves that sink ships. And in a sense, that is an extraordinary leap. Two seemingly disconnected things, you have found an intellectual connection, from a laser in a lab to a wave in the middle of the Atlantic. Can you explain that to us?
So again, in the interest of total precision, the results were always out there. They were in the literature discovered in the 1980s, but they'd been forgotten. And so I guess what I did, along with others, is we just rediscovered this correspondence between the light waves and the water waves. But it was at the right time because, meanwhile, the technology in experiments in light waves developed where we could measure them. And it's much easier to measure a freak wave on an optical table out of light than it is to experience one in real life if you're on a boat. It's not dangerous, it's simple, and you can measure millions of them per second. And so you can really understand their properties and characteristics and statistics and work out how likely they are to be dangerous and under what conditions, and then translate the results back to develop some useful information about freak waves on the ocean.
Richard Feynman, one of the great physicists of the 20th century, gave the Sir Douglas Robb lectures here at the University of Auckland. And you played a key role in conserving and then disseminating the original recordings of those Auckland lectures. Can you tell us a little bit about that experience? What does it mean to you that Auckland was the setting, and why was preserving those lectures so important to you?
So Feynman was a character of physics in every sense of the word, and he was a tremendous educator whose particular way of describing physics wasn't always mathematical, although he was a wonderful mathematician, but he developed a physical intuition which has inspired thousands and tens of thousands of physics students since. Now, I saw these lectures sitting as a student at Auckland. They were occasionally played by enthusiastic students, and when I joined the staff as a junior lecturer in 1994, I saw them in a cupboard, and I thought, what on earth is this doing here again? It's still there. And so I realised at that time how historically significant this was, and I thought, well, we can't have this, and I just got them remastered, and then I contacted Feynman's estate, Feynman's children, the executor, and it's kind of like cold calling. It was the beginning of emails, and luckily at the start of the email age, people actually answered them. And so I got responses from the publishers and from the executors, and then luckily many years later I was lucky enough to be invited to the house of his biographer, where I actually saw some of the famous Feynman artefacts in his books and so forth, and it was wonderful.
Well, thank you.
Right.
On behalf of the many people who I know have savoured being able to go through those lectures and his writings from that time. I didn't realise until yesterday that you also teach a philosophy paper.
I teach philosophy and history of science, yes.
Yeah. So can you talk to us a little bit about the intersection of philosophy and science and why that interests you?
Well, in France, the field is called epistemology, so it's history of ideas in a way. And I think that we often create a hard boundary between the human sciences and the natural sciences. And I think we're starting to see the consequences of that, and the fact that the two communities are not talking to each other, and there's misunderstanding, and there's doubt about what science is and what it should be. Science isn't a collection of facts or things. It's a method, it's a way of thinking, it's a way of asking questions and systematically trying to develop responses that can be verified by other people independently. And that starts to overlap with what philosophy is, and it's a very concrete kind of philosophy, and I think it's something that we need more and more. We need to be able to ask questions of each other, and we need to use the scientific method. I don't really like that term, but that the idea of testing ideas and looking at evidence and understanding what evidence is. And I'm sure Dame Ellen will have the same kind of problems in the courtroom. It's never easy when human beings are involved. It's easier when you're talking about physics, but we're starting to see questions that overlap all the communities, and I think that's always interested me. And there are also all sorts of things about history and philosophy, but that will take hours. So
we're here.
I'll just.
I know this because about 2 minutes after we met yesterday, I shuddered as I heard the words coming out of my mouth when I asked you, does that mean there can be no such thing as true free will? And I thought, and you said, you're forgetting quantum mechanics. And I thought, here's someone who enjoys sparring with his students, and perhaps by engaging the philosophical side of your interests alongside the physics, you were able to tickle two fancies, as it were. Yeah.
Yes.
What do you think of AI?
Well, I'm doing research in AI at the moment, and trying to see how perhaps optical technologies can perhaps replace the silicon-based electronic technologies to reduce the energy footprint of AI systems. AI in general, I think, is a wonderful tool. It allows us to join dots between areas of human knowledge that have been used to train the AI models. But I think it's really important to realize that AI models are trained on a body of knowledge. Now, there may be connections that perhaps we haven't made between the different elements of that body of knowledge. The real problem is that when we think about, can we go outside this trained data set to create new knowledge, I think the answer to that is, at the moment, no. And we have to be very careful. The other problem we have is that while for adults, and looking at the age range in this room, I think a certain class of adults, we've all grown up learning how to read and write and critically think on our own, and to review sources and to develop a certain natural skepticism about what we read. The 7- and 8-year-olds right now who are using AI tools haven't had that previous experience, and I worry very deeply about the next 10 years and what's going to happen to children. And I think we need to develop guidelines, maybe even legislation, to limit the use of AI for the youngest cohorts of our children.
For most people, non-linear optics and ultra-fast laser physics is completely impenetrable as a subject matter. But part of what has distinguished you is that you have spent your career arguing the public deserves to understand science. And this hits on what you just mentioned. It's not just a privilege for specialists, even in an age where the relationship between science and the public is arguably under huge strain. So why does that matter to you so much?
Well, I'm going to paraphrase the statement here of a well-known science popularizer from the 1990s, Carl Sagan. And he said that we live in a world that depends more and more on science and technology, yet the public understands science and technology seemingly less and less. And that gulf between the understanding of science and the need to understand science means that the information being transmitted or used to inform decision makers is becoming disconnected in a very dangerous way from the actual facts and the truth. And that is a recipe for disaster. And we've already seen in the last 5 years some indication of that. And it's just going to get worse unless we do something about it. And I think it's an obligation of every scientist, really, to make some effort to improve that connection.
We'll keep fighting the good fight. We so appreciate your efforts, and we so appreciate you being home. Please join me in congratulating Professor John Dudley.
Thanks very much.